There is only one reason why I don't tattoo Bayes' law on my arm. According to the Torah, I'm not allowed. So you guess that I think that this is a very special law. In fact, in my opinion, this is one of the most beautiful and important theorems in mathematics. Now, in this section, we will talk about the math behind Bayes' theorem and how we can apply it to our localization problems. But I want to take the next few minutes and talk about the philosophy behind Bayes' theorem. When we try to explain the meaning of the word probability to little kids, you usually use examples such as coins, cards, and dice. Let's take this sentence for example. You roll a fair die. The probability of rolling the number 4 is 1 divided by 6. What does it mean? In fact, what we mean is the following, that if we take a fair die and roll it many times, yes, approximately in 1/6 of the rolls, the result will be 4. And as we roll the die more and more, the number of times that we get 4 divided by the total number of rolls will approach 1/6 or 0.1666. The die example assumes that I can repeat the experiment over and over again and roll the die as much as I want. This approach to probability is also called frequentism, from the word frequency, to repeat the process over and over again. It is also an objective approach to probability. Why? Because a probability doesn't depend on you. You can let anyone to roll the die and you will get the same result. But what happens in cases where I cannot repeat the experiment? For example, what are the chances that some candidate will be elected president? Nobody knows. And when I say the chance is 60%, I certainly don't mean that I can repeat the election process over and over again and in 60% of the times my candidate will be elected president. I mean something else. When we talk about singular events, such as elections, events that occur once, the frequent model doesn't really work. So the probability in our case is a subjective approximation of our beliefs in the result. Again, the probability is a subjective approximation of our beliefs. When I say that the probability is 100%, I am saying that I, Roy, am 100% certain, absolutely certain, that the event will occur. And when I say the probability is 0, I mean that I believe or I am certain 100% that the result will not occur. And when I said that the probability is 50-50, what I basically mean is that I have no idea. I cannot know. The definition of probability in a subjective manner or in the Bayesian manner describes my level of certainty in that certain event will occur. The coolest thing is that the math is exactly identical to the math of the frequency approach. Now, the only thing that changes, and this is a big change, is our definition of what probability means. And here we arrive to Bayes' law. Most people land Bayes' law in the following way. The probability of A given B equals to the probability of B given A times the probability of A divided by the probability of B. I don't see Bayes' law like this. In fact, I teach my students to exchange the letter A with the letter H and the letter B with the letter E. Now the equation looks like this. P of H given E equals P of E given H times P of H divided by P of E. What's the difference? H is a hypothesis. This is our initial belief about the world. This is what we think is right. And in the case of self-driving cars, where the car is located. E means the evidence, or what we call reality. In our context, E is the data obtained from the sensors. And the questions that Bayes' law asks is how different is probability of H than P of H given E. If they are not different, we can say that H and E are independent. However, philosophically, it means something much more profound. It means that no matter the evidence, no matter what you see in reality, your hypothesis won't change. And we know people like this, that no matter what happens, their initial belief stays the same. This is a question that we need to ask ourselves. Do we change our beliefs about ourselves according to reality? Does your belief in your ability, for example, to graduate a math degree change after you fail course after course or not? With Bayes' theorem, humanity got two great gifts. For the first time, we can quantify our belief. We can measure how much do I believe in something, to know or to answer to the question how much I believe in a certain thing. With our car, it is how much I believe, for example, that I'm on the right lane. And the second thing, which is I think much more important, is that it got the ability to change its belief according to reality, or in our case, according to the data obtained from the sensors.